Hi all. In today's video, we will discuss about various components of the Kafka architecture, and we will understand how we can use a simple transportation analogy to understand Kafka. So let's go into the details. Terms like Kafka server, Kafka broker, or Kafka node are used interchangeably. Now let's see what's the role of a broker is. Broker acts as the intermediary between producers, which are publishers, and consumers, which are subscribers. Brokers are responsible for persisting records from producers and deliver them to consumers. The functionality of the broker is that broker must be stateful and durable, meaning they reliably store and retain data over time. They help decouple producers and consumers, allowing them to operate independently. A Kafka broker is a Java process and can operate as a part of cluster, even a single node cluster. Brokers contribute to scalability. More brokers can improve IO availability and durability. Broker also manage partitions, which are the basic units of data storage in Kafka. Each partition is led by a single broker called the partition leader, and the data replicated to other brokers, which are called followers. Replicas, the leaders and the follower, help ensure the data durability and reduce the risk of data loss. Now let's see what are the various components in this architecture. So these are the primary components of Kafka. The first one is topic. And in the topics, you can see that we can have multiple partitions. So these partitions can be defined when we create the topic. Here we have producers, and here we can see there are consumers and consumer groups. So producer publishes the data to the topic, and as per the offset, the data is stored in various partitions. And at the end, consumer group contains a lot of consumer which can depend on the configuration, and they subscribe to the topic and consumes the data. So let's understand each and every component here. First of all, a partition is an unbounded sequence of records. It is a basic unit in an event streaming platform, but not very useful alone. A topic is a logical grouping of one or more partitions. Each partition belongs to exactly one topic. Topics are essential for parallelism and load balancing in Kafka. Partitions have a total order, records and ordered. A topic is a union of partition, creating a partial order. This partial order allows for parallel processing while maintaining necessary orders. Think of a topic and its partition as a wide stream with parallel substreams. Even within a substream may have a causal relationship. Events across substream may relate to similar observations but are not causally connected. The term stream is sometimes used instead of topic for a more intuitive understanding. Also, in the previous diagram, we have seen Zookeeper nodes. So let's understand the role of Zookeeper as well. Zookeeper is responsible for electing the controller among Kafka broker nodes. It ensures only one broker is assigned as the controller at any time, and it facilitates automatic replacement of the controller in case of failure or departure from the cluster. Now let's go back to our primary diagram. Here we have producers and consumers as well. The role of producer are that client application that acts at source of data for a Kafka cluster. They communicate with the Kafka cluster using persistent TCP connections connecting to each broker. Producers can publish records to one or more Kafka topics, as we can see in the diagram. Multiple producers can append a record to the same topic, but only producers are allowed to add records. Consumers cannot modify the topics. Now let's see what is the role of consumer. Consumer are client application that acts as data sinks, subscribing to and consuming streams of record from one or more topics. Consumers are more complex than producers because they must coordinate to balance the load of consuming records. Consumers need to track their progress through the stream to ensure efficient and complete data consumption. Now let's understand something about records as well. As we can see, these are the records. By definition, the basic unit of data in Kafka often represent as an event. This is called a record. There are various attributes of record as well, like key, value, headers, partition number, offset, timestamp, etc. On the right, we can see the consumer group as well. So producer sends records to the topic organized into partitions. A consumer is a process or a thread that connects to Kafka to read records. And consumer often operates within consumer group, which are Kafka load balancing mechanism. Kafka also provides load balancing. Partitions are distributed among consumers in a group. As more consumers join, the partitions are redistributed to balance the load. If a consumer leaves, the remaining consumer takes over the partition. Each consumer in a group is referred to as subscriber, collectively functioning as a single entity. Subscribers in a consumer group cannot interfere with each other's data consumption. Consumer reads records from partition without deleting them, preserving the data for other consumers. And each consumer tracks its progress through a partitioning using offsets. Kafka distinguishes between the head and the tail of partitions, that is the latest record and the oldest record. Kafka also assigns partition to at most one consumer per consumer group to ensure data consistency and processing safety. This assignment mechanism ensures that no record is processed by more than one consumer in the same group simultaneously. Consumer group enhances availability by relocating partitions from non-responsive consumers to active ones. Consumers signal their health by regularly reading from topic, preventing relocation of their partitions. Now let's understand it in more detail. Here on the screen, we can see that we are having an image of a highway and there are various lanes in this. Also, there are records, or we can say car here. And we can say that every car must be having some passenger. And finally, there is a off ramp. You can see here there is an off ramp. Now let's try to understand this, how Kafka works in terms of transportation analogy. Imagine you are driving on a highway. The highway itself represents a topic in Kafka. Here we can see the highway as a topic which is the data flows. Now, highways typically have multiple lanes. These are like partitions. Like a partition can be considered as one particular lane. And Kafka divides flow of data into separate streams. Now let's talk about the cars on the highway. Each car represents a record. Here, these are our records. And inside each car, you can have passengers. So all these 005, 010, these are passengers. And these can be values stored in the record or in the car. Many cars or records can travel on highway at the same time, but they stay in their own lane, that is the partition. Cars in the same lane follow one another in orderly manner, just like records are stored and processed in a sequence with a partition. At some point, each lane on the highway leads to off-ramp. Off-ramp is our consumer, which directs cars to their destination. In Kafka, this off-ramp is consumer, which takes in data from partition. If one off-ramp gets backed up with traffic, meaning one consumer is overloaded, the cars in the other lane or partition can still flow smoothly through the respective off-ramps, allowing other consumers to keep working effectively. Now, when we create a Kafka topic, we can choose how many partitions or lanes we want. These partitions are evenly distributed among the consumer group. Each partition is assigned to only one consumer within that group, ensuring no two consumer process the same partition at the same time. Kafka uses this system to handle large volume of data efficiency, allowing multiple or millions of records to be processed smoothly, just like how a well-designed highway can handle a lot of traffic. So that was all for today's video, and we will understand how Kafka works and how it interacts with Spring Boot in our next videos. Thank you.